Hello everyone, this is question number 1024, sum of subarray question, which is LeetCode medium, but is not that medium that it looks. The question description states that you are given an integer array nums. The range of subarray of nums is the difference between the largest and the smallest element in the subarray. Means first we have to find out all the subarrays which can make by this nums, and after that we have to find maximum and the minimum in each subarray, and by subtracting and adding all these ranges we got the answer of this question. Just like the subarrays are 1 1 2 1 2 3 2 2 3 and 3. Here maximum and minimum both are same, so range is 0. Here maximum is 2 and minimum is 1, so range is 1. Maximum is 3 and minimum is 1, so range is 3 minus 1 is equal to 2. Here maximum and minimum both are same, so range is 0. Here maximum is 3 and minimum is 2, so range is 1, and here also 0. So the brute force approach we can follow is by using to loop. We use to loop to find all the subarrays, and we make 2 pointers. First is max and maxi, and second is mini, and by comparing we can got the difference of max and min, and we adding and give the answer. So brute force approach looks like we have to make 2 for loops, and one maxi is equal to int min, and mini which is equal to int max, and by comparing and subtracting we can got your sum. So let's see the code of brute force. So here is the code of brute force approach. We have first created a long sum is equal to 0, because sum can be in beyond the range of integer. We have a loop up to size. We created a mini which is int max. Firstly we assume that it is the highest integer, and maximum it's the lowest integer. And the second loop which started with I, because we want to find out all the subarray. It is the format to find all the subarray by using to loop. If num of j is less than mini, तो mini को हम अपडेट कर देंगे. If maxi, तो maximum को अपडेट कर देंगे. And sum is equal to maxi minus mini. We have to find all the maxi minus mini of all the subarrays, and after that we return the sum. So this is a brute force approach. This takes order of n square time, which is not an optimal solution. So for the optimal solution we have to think beyond it. So for the optimal solution, first we have to find out the how many subarrays we can form from these 1 2 3. We first have to find out the min of the subarray and max of the subarray, the sum of min and sum of max. And at the last, just like we do in above, that we first just like we compare max minus min, and we do whole sum. So if we distribute sum between them, so sum of max minus sum of min will also give the same result. So if we find out all the maxi, means we found all the subarrays, and where maxi just like take 1 as the max, and how many subarrays we can create where 1 is the max. Just like we take 2 as the max, and how many subarrays we can create taking 2 as the maximum here. Just like 3, we take 3 as max, and how many subarrays we can create with 3. If we find out how many subarrays we can create where 3 is the maximum, then this number n multiplied by 3 is equal to how many subarrays where 3 is maximum. So this is the number 3n, 2n plus n. So this is 5n. So 5n is equal to sigma max, and just like we found out sigma min, and by subtracting these two we get our return result. So how can we find out this? So let's take another example. Nums is equal to 4, minus 2, minus 3, 4, 1. So let's take that here minus 3 is our element. Okay, and we have to check that how many subarrays we can form where -3 as the maximum. Taking -3 as the maximum, how many subarrays we can form? So here we check, is 4 is less than -3? No. Is -2 is less than -3? No. So we can only form one subarray where -3 is maximum. Similarly, take -4 as the maximum and we check how many subarrays we can form where -4 is the maximum. Nothing, no any event will be maximum more than 4. So mine 1 is more than 4? No. So we can take this subarray. Is -3 is greater than 4? No. -2 is greater than 4? No. 4 is greater than 4? No. So we can take all the subarrays where 4 is included, means 4 is compulsory. So how can we find out this? So the formula for calculating this, just like this, if this is a index I and this is -1 and here is n, so formula is n minus I into I minus of -1 gives the total number of subarrays we can form where I is included. Let's take it is equal to right and this is equal to left. So this is the formula where right minus I into left minus into I minus left is equal to P. It is equal to total number of subarray where this I, this index is included, and when we multiply this with nums of I, we get the mini sum. Of the 4. Similarly, we can find for -3, -2, 4 and 1. So how can we check that this index, in which index the number is greater than this? So for this we have to create a monotonic stack. We create a monotonic stack of next greater element, the element which is greater than 4. So here we find out nothing and here we found out nothing. Similarly, if we check for -2, so 4 is greater than -2, so we found out left as 0 and -2 -3 is less, 4 is greater. So here find out this, which is third index. So at 0 and at third, these are the previous next greater and this is the next greater. This is the previous next greater and this is the next greater. But here is a problem, when we got duplicate numbers, so from one side we have to include it and from the other side we don't have to include it. So I think you got some understanding of the question. So let's see the code. So in this way, similarly you found out sigma max, and similarly the condition you have just like similarly reverse it and you find sigma min, and by subtracting these two you got your answer in order of n complexity. So space rather is order of n, but your time complexity has been decreases from n square to order of n. So here is the code for, we have first find max sub sum array, which is sigma m, capital M. Okay, so first find the size, long sum max is equal to 0. Next greater elements means the element which is next greater than that index. Okay, and next previous greater equal elements means one time we include if there is any equal element present and one time we exclude it. Okay, so for the correct result we created two monotonic stacks, which for the first monotonic stack stores the next greater elements index. We store the index because we have the work of index. Okay, and second is for the previous one, and we loop for n times from the previous for the next greater element. This is the loop for next greater element. Okay, we are first check if stack is empty, nums st1 top dot dash is less, means whenever up to which our stack top is less than nums of I. Here we found the maximum, means up to which we doesn't found any maximum in the stack, we have to pop it out. After that if we find out any next greater element, if it is empty means we doesn't find anything, means no element in the stack or in the array is greater than that index, so that will point to the last index, means n, and means last the beyond last plus 1 means n. And if we found out, then simply store the st1 dot top and st1 dot push I, means store the index, and this loop for the previous one, for which this loop is for the previous one. So for int I is equal to 0, I less than I plus plus. So here is the condition. What this condition not includes the equal. It not includes equal because we have to first one time considered if there any equal element is present. So this index should also be considered in the previous case. We can consider it in any case. We can consider it above or below, your choice. If we found out any equal or greater than element, st2 top pop, and if we found out npge means next previous greater equal element of I is equal to, if empty, this means we doesn't found any previous greater elements, so we simply store the -1 index, means the beyond 0, and if we found out, then this store st dot top and then st dot push index. Okay, then this time this is the time to calculate the sum. So here we first find out the right length is ngi minus I, and left length is equal to I minus npgi. And what is the contribution of this length in the summation? It is long right into left and into nums of I, means right into left is the length, total length, and nums of I is the value. So this is equal to contribution, and sum max plus is equal to contribution. So this is creating the sigma capital M and return the sum max. Similarly for find sum min, similar things is happened. This here is the next smaller element, and just we have to reverse the condition. Here is greater than equal to, where is less than equal to, here is greater than equal to, means we have to find out the next greater element after that index, and we just check the condition. If not found, then means similar condition, we just have to reverse the condition, reverse this sign. And here also we considered one time equal element, and after that we created the right length, left length, contribution, and sum min plus is equal to contribution. And after that in the function long subarray return the find max of nums minus find min of nums, and this is your answer. So thank you.